Good morning, everyone. Today, in applications of dimensional analysis, we have to see the third application, and that application is very simple to to check the correctness of physical equation. Correctness of physical equation. In board book, the same application is mentioned in this way to check the truth of physical equation. Just we take only one single example. For example, there are three kinematical equation. The first kinematical equation is V equals to U plus AT. Second kinematical equation is S equals to UT plus half of AT square. And the third kinematical equation is V square equals to U square plus 2AS. Now here we have to find out the correctness of physical uh, equation, that is the dimensions of, just I will take this second kinematical equation as an example. The dimensions of S, the dimensions of UT and the dimensions of half AT square are constant or not, that we have to see. If the dimensions of S, UT and AT square are same, then we have to say that this equation is a dimensionally correct equation. Otherwise, this is not a correct equation. So first of all, what is the symbol of each term? That is, what is the meaning of S? Okay, so I will write here, for example, the second kinematical equation. Kinematics is a branch of physics where we study the motion, and these are nothing but the Newton's equations of motion. There are three equations of motion. For example, second kinematical equation is S equals to UT plus half AT square. Here the S means what? S is my displacement. So I will mention here S is my displacement. U into T. Okay. Here what is U? U is my initial velocity into T means time. Then half of 80 square. Here the number has no any dimensions, so we calculate the dimensions of 80 square. Here A stands for the acceleration into T square means my time square. Now we have to see in detail the displacement. Therefore the displacement is nothing but the shortest distance from mean position. Here we are measuring the dimensions of displacement. SI unit is a meter. Therefore m raised to 0, that is a mass raised to 0. There is only length raised to 1 and t raised to 0. These are the dimensions of displacement. I will say that is my equation number 1. Then calculate the dimensions of ut. Initial velocity. Velocity, its SI unit is meter per second. Okay, or its unit is meter per second. So when I calculate the dimensions, meter is in numerator part. There is no any term or no any unit regarding the kg or kilogram. Therefore mass raised to 0, length raised to 1, because meter is a unit of length and which is present in the numerator part. And second, that is a unit of time, but there is only one power for a second and it is present in the denominator. Therefore it becomes a second raised to t raised to minus 1. And the dimensions of time, unit of time is a second. There is only one term, so I will write in this way. If you check this, if the base is same, here the term is m raised to 0, l raised to 1, t raised to minus 1. and multiplied by time, that is m raised to 0, l raised to 0, t raised to 1. Here m, l, t are the base and 0, 1, minus 1, 0, 0, 1 are the powers, and in between them there is a multiplication. If the base is same, if the base is same and there is a product, then we add the powers. Therefore m raised to 0 plus 0, it becomes a m raised to 0. L raised to 1 plus 0, here 1 and is this 0. T raised to minus 1 plus 1, it becomes a 0. So therefore only term remains is L raised to 0. So I will write again m raised to 0, L raised to 1 and T raised to 0. These are the dimensions of ut. Now come to the next part. In the next part, the only one term remaining is half of 80 square. Half 1 by 2 is a number. The dimensions are only for the physical quantities. So I calculate the dimensions of 80 square. Okay. How I calculate the dimensions of 80 square? 80 square means acceleration into time square. Unit of acceleration is meter per second square. So the dimensions becomes m raised to 0, because meter means meter, and here capital M stands for the mass. Therefore no any term related to kilogram. Therefore mass raised to 0. Meter is a unit of length which is present in the numerator. So L raised to 1. Second square is a unit of time square, but it is present in the denominator. So I will write as a minus 2. Now afterwards, the next term is a t square. T square means a time square. T stands for the time. Therefore m raised to 0, mass raised to 0, L raised to 0, but T raised to t square. So it becomes a plus 2. Again the base is mlt. Powers are different, but in between them there is a product. Therefore we add the powers for a common base. So 0 plus 0, 1 plus 0, t raised to minus 2 plus 2, and your final answer becomes m raised to 0, L raised to 1, t raised to 0. Therefore the dimensions of acceleration and time square. Now I will write here at square equals to m raised to 0, L raised to 1, t raised to minus 2 into m raised to 0, L raised to 0, t raised to 2, and finally it becomes m raised to 0, L raised to 1, t raised to 0. This is my third example. Third equation. If you see all the equation number 1, 2 and 3, then we conclude that in all the equations the dimensions are same, means the dimensions of S, dimensions of ut and the dimensions of 80 square are same. Therefore this equation is a physically correct equation. Okay, is it clear for all the members? Yes, please tell me, is it clear for all the members? Okay, now we see the next part. In the next part, we see the next applications of dimensional analysis. That next application of dimensional analysis is what? That we have to see. Okay, the next application of the dimensional analysis is, I will mention here, the next application of dimensional analysis is establishing a relation between or relation among different physical quantities. So I will write the title, establishing establishing relation among different physical quantities. Now suppose A is my any one physical quantity. Okay, A is my one physical quantity, And this physical quantity A depends on some other physical quantities. Let that physical quantities are x, y and z. Now I relate this A with x, y, z in this way, that is A is proportional to x raised to small a, y raised to b, z raised to c. Then what is the power of x? What is the power of y? What is the power of z? If we get that power, then we can easily relate how A is related with x, how A related with y, and how the A is related with the z. Okay, just we see. And this establishing this relationship, we can easily find out using the dimensional analysis. So see the one example. What is that example that we have to see? This is one very simple example from 9th standard. We see that formula. The time period of a simple pendulum. Okay, I will mention here. Time period of simple pendulum is depends on, afterwards we can create a formula, is depends on length of pendulum and acceleration due to gravity. Everyone know that the acceleration due to gravity, its average value is 9.8 meter per second square. Length of pendulum we can express symbolically as a L, and acceleration due to gravity as a G. Okay, now we have to, I will write here, T is directly proportional to L and G. Okay, time period is proportional to L and G. Now here proportionality sign, if you want to remove that L raised to A and the G raised to B, okay, we have to find out the powers of L and G, then we easily relate this. So okay, now we have to remove that proportionality sign, so we add a one constant. Okay, this constant is a dimensional constant, k into L raised to A and G raised to B. Now you find out the powers of L and G. How you find out the power of L and G? K is a dimensional constant, therefore it has no any dimensions. First of all, we calculate the time dimensions of time period, then dimensions of L and the dimensions of G. So I will first calculate the dimensions of T. So I will write here dimensions of T. T means what? My time period. So dimensions of T are, unit of time period is a second. So m raised to 0, L raised to 0, T raised to 1. Okay, this is the first part. Then the dimensions of L. That is the length is there. Therefore m raised to 0, L raised to 1 and the T raised to 0. Okay. Then the dimensions of G. That is the dimensions of acceleration due to gravity. The dimensions of G are, unit of G is meter per second square. So meter, therefore m raised to 0. Meter is a unit of length and second square is a unit of time period. Therefore it becomes m raised to 0, L raised to 1 and the T raised to minus 2. Now we can use this relation, that is a T equals to K into L raised to A, G raised to B. So I will write in dimensions form m raised to 0, L raised to 0, T raised to 1 equals to, that K has no any dimensions because that is a constant, L, that is m raised to 0, L raised to 1, T raised to 0 raised to A into m raised to 0, L raised to 1, T raised to minus 2. These are my dimensions of acceleration due to gravity raised to B. So now here forget the K. then we are getting m raised to 0, l raised to 0, t raised to 1. This is equals to here raised to a. Okay, m raised to, just see the one example, x raised to y raised to b. Then here power of power, so it becomes x raised to y into b. I can use the same thing here. Okay, laws of indices. Therefore I will write k as it is. Here m raised to 0 into a, it becomes a 0. L raised to 1 raised to a, therefore it becomes a 1a. T raised to 0 raised to a, so it becomes a t raised to 0. Again m raised to 0 raised to b, so it becomes a m raised to 0. L raised to 1 raised to b, so it becomes a L raised to b. And here t raised to minus of 2b. Okay, is it clear for all the members? Again we have used the one more relation or one more application of the or law of indices. If the power is, if the base is same and the powers are different and in between there is a multiplication, then we add the powers, so it becomes a k into m raised to, here in both the cases 0 plus 0 0, l raised to a and b, so it becomes a l raised to a plus b, and t raised to 0 and minus 2b, so it becomes a minus of 2b. Okay, now we can analyze in simply way. M raised to 0 and here m raised to 0 doesn't matter. L raised to 0 and here L raised to a plus b, means can I write in this way? A plus b equals to 0. Okay, this is one thing. And in second equation, here t raised to 1 and here t raised to minus of 2b. Therefore, can I write in this way? Minus of 2b equals to 1. If minus 2b equals to 1, then b equals to what? B equals to, or 2b equals to minus 1. Therefore, b equals to minus of 1 by 2. Here I am getting very important relation, b equals to minus of 1 by 2. Okay, here a plus b equals to 0. So I will write a equals to minus of b, that is a equals to minus, and value of b is minus of 1 by 2. So the term becomes a equals to plus of 1 by 2. Using these relations a and b, can I write the same thing here, that t equals to k as it is, a raised to plus 1 by 2 and b raised to minus of 1 by 2. Raised to 1 by 2 means root term. So therefore here a means, extremely sorry. Here L raised to 1 by 2 and g raised to minus 1 by 2. Therefore raised to 1 by 2 means in root. Therefore I will write there is a plus, so it is in denominator. And there is a minus of 1 by 2, so it is in denominator, minus g. And here the constant is 2 pi, and we are getting in root L by g. In this way we can derive the formula of a time period of a simple pendulum. And here we can, here this time period is depends on L and g, but how the t relates with L, how the time period is relates with g, that we don't know. Therefore we can find out the time period how relates with the L. Then I can easily conclude that time period is directly proportional to the root of length. How the time period is related with the g, that relationship we can establish using this dimensional analysis, that is a time period is inversely proportional to the root of g. Okay, everyone note down this and solve some examples regarding this. Okay, thank you.